Okay, question 4 is the organic reaction question. First question asks for the type of reaction illustrated by reaction A. Reaction A has got an alkane that is reacting with a halogen, in this case chlorine. So alkane plus a halogen, that kind of reaction is a substitution reaction. 4.2 asks for the conditions for substitution reactions, and that's just UV light. 4.3, the IUPAC name of the major product in reaction B. There's reaction B. And to answer this question, we need to recognize that there's a double bond there. So that's but1ene reacting with HBr. I always think it's easiest to draw it out, so let's draw out but1ene. There we have it. If we're going to break that bond and form two new bonds, we're then going to put hydrogen and bromine on one of those. And Markovnikov tells us that the hydrogen will go on the more substituted carbon, so that's carbon number 1, and the bromine will then go on carbon number 2, which means that the product is 2-bromobutane. Type of reaction illustrated by reaction C. There's reaction C. In this case, we've got an OH group, a hydroxyl group on carbon 2. So that's butane 2-ol. And the conditions are that it's reacting with sulfuric acid with heat. And so that's going to give us an elimination reaction. In this particular case, it's a dehydration reaction, but elimination is perfectly fine. All right, 4.5, draw the full displayed structural formula of the major product of reaction C. I've just drawn out the reactant there, butane 2-ol. And we have to decide which of the hydrogens are going to be removed during the elimination reaction. And carbon, let's just number the carbons quickly, numbering from the left to give the OH the lowest number. So either the hydrogen on carbon 1 will be lost or the hydrogen on carbon 3. And the rule says that the hydrogen on the least substituted carbon, in other words, carbon number 3, will be lost. And so the hydrogen on carbon 1, that carbon atom has 3 hydrogens. The hydrogen on carbon 3 has only got 2. And so it's the hydrogen on carbon 3 that will be lost. And there's our water that's removed, giving us the double bond. And so if we fill in all the rest of the hydrogens, there's the full display structural formula for the major product. Obviously it's but2ene. Alright, 4.6. This question's about 2-chloropentane, 4.6.1. It's asking which reaction will take place in the presence of concentrated sodium hydroxide in ethanol. And that's your clue for the elimination reaction that takes place. 4.6.2 asks for the IUPAC name of the major organic product formed in this reaction. Let's have a look carefully. There's our 2-chloropentane, and it's going to react in the presence of sodium hydroxide and ethanol. Again, we have to decide which hydrogen is removed during elimination, and as before, the hydrogen is lost from the less substituted carbon. So in this case, it's carbon number 3, and so the H on the right hand side and the Cl will be removed and a double bond will be formed. And so the name of our product is pent2ene. And then finally the structural formula, using structural formula to write down balanced equation for the reaction of 2-chloropentane with dilute sodium hydroxide. There's our 2-chloropentane and our sodium hydroxide, and that reacts to form, it's a substitution reaction, so the Cl is lost and the salt sodium chloride is formed, and the OH is substituted onto carbon number 2, so it will be pentane 2-ol.